want you to think about the first thing that comes into your head when you hear the words nanoscience and nanotechnology. For some of you, it's probably something fantastic, right? Like Fantastic Voyage or Star Trek, right? Nanotechnology can take us somewhere we've never been before. For others of you, it could be something fantastically sinister. Like nanotechnology can take the form of robots injected into our bloodstream that can turn us into zombies. Thankfully, neither of those are true yet. Okay? But for most of you, nanoscience and nanotechnology is probably something that sounds kind of cool and you don't really know what it is. Well, let me tell you, it's not that difficult. It's just the study of materials and devices that are at the nanometer scale. In other words, they're really small. How small is the nanometer scale? Well, things you can see are on the order of the size of a pinhead. Okay? That's about 1 millimeter in diameter. Okay? Things you can see with an optical microscope are 1,000 times smaller than that, like a red blood cell, and they live in the size range of a micrometer or so. 1,000 times smaller than the red blood cell is where nanotechnology lives, at the nanometer scale. These are some quantum dots that are a few nanometers in diameter, and you need special electron microscopes to see them. Okay? Now, what is really fascinating about nanotechnology is that when you shrink materials down to the nanometer scale, they start to behave in ways that are not so familiar to us at the macroscopic world. For example, most of us are familiar with gold, right? Shiny, usually yellow metal. But if you make gold and shrink it down to tiny particles at the nanometer scale, gold actually looks pink, it turns out. Now, this is not so foreign to most of you, right? Because if you look up at a stained glass window, the red stained glass there is actually due to scattering of light from metal nanoparticles. Okay? So this is technology that's been around for thousands of years in some level. We're familiar with carbon, especially after summer barbecuing, right? In the form of coal, kind of brittle, black, nasty stuff. But if you take carbon and you lay it out into a hexagonal sheet, and you roll that thin sheet up into a cylinder, you have something called a carbon nanotube, a truly remarkable material. I mean, carbon nanotubes can conduct electricity 10 times better than the copper in this building for the same diameter. They are also 10 times stronger than steel, but only a fraction of their weight. And they're the only material we know of that can be either semiconductors or metals, depending on how you grow them. Truly remarkable. Right? Now, what about semiconductors, or minerals, as we commonly know them? Right? If you take a semiconductor and you shrink it down to the nanometer scale, for example, these quantum dots you see here, and you change their size, you can actually change their color. Right? So you can actually tune the emission, this is fluorescence, from these quantum dots to have any color in the visible spectrum you want, any color of the rainbow, from red to blue, just depending on their size. So I hope I've shown you that at the nanometer scale, size matters, right? So before nanotechnology, the properties of the material were just due to the chemical composition. You couldn't really change that. But now when you make things really small, you have this other knob you can tune. Right? You can change size and shape, and that changes properties dramatically. And this is totally a new way of thinking about building blocks of matter. So there must be something cool we can do with this, right? You're probably all thinking, I need to get my hands on some of that nanotechnology. Where can I buy it? Well, let me show you the most advanced nanotechnology product on the market today. It's a television. Pretty exciting, huh? Actually, I just saw it in Best Buy recently. It is a gorgeous TV with beautiful reds and greens, but we've had TVs for a long time, right? And if you press me and you ask me 10, 20, 30 years from now, what will nanotechnology be involved in? I'll have to be honest with you. I don't know, right? People in general are very bad at predicting where technology is going to go so far in the future, especially scientists, actually. As an example of that, I want to show you this story about something you may have heard of called the laser. So the laser was discovered in 1960. The first laser was built by Theodore Maiman at Hughes Laboratories. It was then engineered at Bell Laboratories as well, soon after, right? And before 1960, light was only known as light bulbs. incoherent radiation, bathing everybody, right? But after the laser, we had something called coherent radiation. You could focus it. You had laser beams, right? Exciting stuff. Totally new way of thinking about light. What can we do with that? Well, the many Nobel Prize winners at Bell Labs, their quote was, you see it on the screen, "Good job, guys. What are we going to do with it?" No idea, right? They didn't know. They couldn't look that far in the future. If we pan ahead 50 years, we know that, you know what, I'd still be in Wegmans in the checkout line this morning on a Saturday morning, right, if it wasn't for the checkout scanner, which is a laser. It's based on a laser, right? Students coming to the University of Rochester would actually have read books before getting here if it wasn't for the laser, because there would be no Wii, there would be no PlayStation, there would be no DVDs or Blu-rays, all based on a laser. Great advances in medicine and dentistry due to a laser. For example, you can now easily remove that tattoo of your ex-boyfriend, okay, due to a laser. And we do have much more efficient ways of killing each other because of a laser. The upshot of this, though, is that collateral damage has been reduced by orders of magnitude with our smart weapons. Okay? None of this could have been predicted in 1960. None of it. Okay? So for the remainder of the talk, you can take everything with a grain of salt, because I'm going to tell you where I think nanotechnology may go in the next 10 or 20 years. And one area is solving the energy problem. You know, we use a lot of energy in this country and around the world. You can just see that by looking at a map of the United States at night and how much energy we burn. You can find Rochester easily on the map. You can even find Utica, something like that there as well, right? But working with Rich Eisenberg in the chemistry department here at the University of Rochester, we have taken quantum dots, these little semiconductor particles at the nanometer scale, mixed them with water, added some vitamin C, and then added nickel salts. This is like table salt, sodium chloride, where we replace the sodium with nickel, and we just let it sit out in the sun. And what we generate is hydrogen, a lot of hydrogen. And hydrogen can be put into a fuel cell and then burnt. The only byproduct is water, right? And you can use that to generate electricity to power your house, or in this case, to power a cool-looking Mini Cooper automobile, right? However, I drove here in a gasoline-powered car. I'm very happy with it, right? It works well. This may save the planet at some day, small thing like that, right? But it won't change my life immediately. I'm happy with the gas-powered car. Is there something nanotechnology can do potentially that you just can't have done right now? It's impossible, right? Almost fantasy. Well, we think that may be in the area of imaging. Okay, so there are many different kinds of imaging. Ultrasound imaging is a great form of imaging technique. It is completely non-destructive. You can get wonderful three-dimensional images. You can image in really difficult environments like water or the body, and you can image in real time. The problem with ultrasound imaging is it has terrible resolution. This image is actually an ultrasound image of my nephew, Cameron, when he was inside my sister. And she was very excited. She emailed me this image, and she said, "We're having a boy. Look at the arrow." I can't tell, okay? Clearly, we need better resolution to see that. So if we had ultrasound imaging at the nanometer scale, right, 1,000 times, 10,000 times better than what we have now, what could we do with it? Well, one thing you could do with it is you could image cells, not just whole cells, but parts of cells. You could image proteins or enzymes on the surface of cells, or maybe inside of a cell. And in the same way that we use the ultrasound image of the growing baby to tell the health of the baby, we maybe could use an ultrasound image of the cell parts to tell how healthy the person is. Maybe use this someday as a way to treat and diagnose disease. Okay? Now, the problem with that is there are no ways right now to generate ultrasound frequencies high enough to get nanometer scale images. It's just impossible, right? Until the development of these carbon nanotubes. They actually can vibrate with frequencies high enough to get wavelengths short enough that you can potentially get ultrasound images. And we're far, far from that right now. But we're starting along in this direction, and we're very excited by it because it has great potential. So in summary, nanoscience and nanotechnology, game-changing technology, right? For now, before nanotechnology, you only had what you were given chemically as a material. You couldn't change it. But when you make it really small, you can tailor its properties based on size and shape. Size matters now. And what we think is someday nanotechnology will enable things to be possible that currently are not possible. Some people think big, in our research, we tend to think very small. Thanks very much.